focus on first when it comes to factoring is the special case of common factoring. The biggest piece of advice I have for you as we're starting to work into our algebra units are if you ever have to factor something, always try to look for common factors first. When we're trying to find a common factor, the easiest way is to look at all the terms of our polynomial and see if we have a GCF that's not equal to the number 1. If our GCF is not equal to the number 1, then we're going to take out the GCF from each term and rewrite our original polynomial as some kind of product of polynomials. So to take a small example here, we have 2x plus 4x squared. Now our first term can't be broken down any further than the number 2 and the variable x. Our second term, our 4, can be broken down into 2 times 2, and our x can be broken down into x times x. So we can see here that the shared values between both, or the shared factors between both, are the factors 2 and x. So we're going to pull that GCF outside of our original polynomial and see what's left over. So what we try to do is divide each of these by the GCF. 2x divided by 2x is 1. 4x squared divided by 2x is 2x. To finish off our lesson, we're going to do a little bit of common factoring. So let's take a look at our first expression, which is 12a to the 5 minus 32a squared. If we would like to factor this, we need to find the GCF of 12 and 32. The GCF of 12 and 32 is the number 4. And then after we have that, we move on to each one of our variables. We only have one variable, that's a, and we look at how many shared factors each monomial has. Our first monomial has 5 factors of a, and our second one has 2 factors of a. Remember that we take the fewest number of factors to get our GCF. Now we go back and we divide each monomial by this GCF. So in my mind I'm thinking, well, what's 12a to the 5 divided by 4a squared? 12 divided by 4 is 3, and we can use the subtraction rule for the powers of a. So we get a to the 5 minus 2, or a to the 3. This is the value that's going to go in our first spot in our new factored polynomial. And we can do the same process with 32a squared. We could divide this by 4a squared. 32 divided by 4 is 8. And if we use the subtraction rule for our variable a, we get to the 2 minus 2, or a to the 0, which is equal to 1. So this becomes our second term inside of our factored polynomial. Now let's take a look at a bit of a larger example over here with 3 terms. We have 8x squared y squared minus 4x squared y plus x squared. Now if we go through just our numbers first, we see that 8, 4, and 1 don't share any common factors except for the number 1. So we don't have any numbers that come out when we do our common factoring. Next, let's go through each variable, starting with x. It looks like each of our terms has an x squared factor, so we can bring that one outside. And if we look at our y's, the first term has 2 factors of y, the second term has 1 factor of y, but our third term doesn't have any factors of y. So we do not have any factors of y that are going to come out into our GCF. And again, to get our terms that are going to go inside of our factored piece, we could divide each of our 3 terms up top by x squared. 8x squared y squared divided by x squared is going to leave us with 8y squareds. 4x squared y divided by x squared will leave us with negative 4y. And finally, x squared divided by x squared is equal to 1. All right, my little epsilons, stay positive.